Good evening, all. Welcome to day 4 of the AICTE ATAL FDP on AI and Data Analytics for Sustainable Development Goals. We are delighted to welcome Mr. Ankit Hegde, Program Manager at IDH, who will be delivering a session on sustainability driven quality assurance in modern manufacturing ecosystem. Now I request Dr. Prasanna Kumar Sir, Associate Professor, Department of CSC, to introduce our chief guest to the audience.
Am I audible?
Yes, sir, you're audible.
Yeah, good evening. Good evening, everyone. Myself, Dr. Prasanna Kumar, Associate Professor, Department of Computer Science and Engineering, RNSIT. It's my pleasure to introduce Mr. Ankit Hegde, an accomplished electrical engineer with more than 15 years of international experience. Over the course of his career, Ankit has worked across diverse domains including sustainability, supply chain management, operations procurement, business development, design and development, quality inspection, and project management. Currently, he serves as the program manager at IDH, the Sustainable Trade Initiative, where he leads sustainability strategies and ensures quality assurance in factory assessments across India, Vietnam, Cambodia, and Indonesia. His work has been instrumental in creating safer and more sustainable workplaces while fostering collaboration among engineers, auditors, and stakeholders. With strong analytical skills, leadership qualities, and passion for sustainability, Ankit has successfully managed complex multi-stakeholder projects and continues to be a driving force in advancing responsible global supply chains. We are happy to welcome you, sir. I request you to take the session. Thank you.
Hi, thank you so much. Thank you so much for the introduction, and thank you to the team of RNS who have invited me to be part of the whole event and also to conduct this session for all of you today. Good evening once again, and let me just share my screen. So can one of you confirm if the screen is...
Yes, visible.
Okay. Hi, welcome again. I will be today talking about sustainability-driven quality assurance in modern manufacturing ecosystems. I've already been introduced, I'm a program manager in a program called Labs Initiative. It's a company based out of Netherlands, and we basically currently work on a lot of sustainable goals, but specifically on Sustainable Goal 8 and 17, which I'm sure in the course of these days you have heard a lot about sustainable goals, and I think some of the content that I might be presenting today might feel repetitive to you, but I would bring it to more relevance to the subject of sustainability and quality assurance in the manufacturing ecosystem specifically. So over the course of the 1.5 hours, or probably 1 hour, 10 minutes, and then I will open up the session for question and answers, if any. I will briefly introduce about the topic, and then we'll talk about the UN Sustainable Goals. Then I will dive into the relevance of the sustainable goals in manufacturing ecosystems. Then how the sustainability and QA intersect in modern ecosystems. Importance of aligning the product quality with environmental responsibility, which right now becomes the whole premise of why we are working on sustainability. The key principles of sustainability driven quality assurance. Then there is one case study that I will just show you briefly, which is also a good practice that we've seen in the market, which maybe you can also read about more case studies when you go back, and you can find a lot of those content online. Then I will specifically be introducing you the concept of SDG 8 implementation, which is something that we work on more so on the textile industry. The benefits and challenges in implementing this setup or a system, then we'll conclude and then I'll open it out for question and answers. First up, on the introduction of the whole quality assurance concept. So in this era where advanced manufacturing and environmental awareness is on the rise, quality assurance is not going to be just limited to product durability and a compliance check, or just to see how the manufacturing process is working and the product is coming out. Currently, it is also playing a central role in achieving the sustainable, safe, and social responsible manufacturing. So responsible manufacturing is a term defined hugely in the market by pretty much all the brands that you see globally, is to have a healthy value chain. And when I say value chain, it starts from the raw materials and it ends up wherein you see the end product. Through the whole value chain, everybody is safe, secure, and the environment is also taken care of. So the integration of sustainability principles and safety standards into this whole quality assurance framework is very important, and that's how organizations can now deliver products that are not only talking about quality and the longevity of the product. It is also now talking about making these products safe for the users and also to the producers and consumers, when I say users, and also be making it more kind to the planet. So with that, I will talk about the basic definitions of QA and sustainability, and then I'll take it forward. So basic definition when you talk about quality assurance. What is quality assurance? It is a systematic process that we are all aware about, wherein we ensure that the product and the services meet a specific requirement or a standard. So while we talk about quality, then we only focus on preventing the defects through the process control, wherein the manufacturing facility has to ensure that there are no defects in the product that is coming out of the manufacturing facility. Second thing is to then ensure there is consistency in deliverables and the reliability of the output is there. Then there is a continuous improvement process or a system, which is very important these days. When we talk about sustainability, the whole importance is about continuous improvement. It's not only about the manufacturing system. Probably even in a college, when we are handling students and we see how the management is functioning, there is always room for continuous improvement, and that is something that everything in every process in our life we follow, and that is something that is there in quality assurance as well. Then comes the main part of compliance with the industry standards and regulations. There are quite a lot of standards that are defined globally. No, it's not that one product is manufactured in a particular country and then only those standards are relevant in that setup. Care has to be taken that the global regulations and global standards is also taken into factor while the manufacturing process is followed. When we talk about sustainability, sustainability is all about minimizing the negative impacts. It can be environment, it can be energy, natural resources, and then also at the same time, making that whole setup of manufacturing facility to be safe for the employees, the communities that are around these manufacturing factories or setup, and also then for the consumers. So for that, the emphasis is more so laid on the effective usage of the resources in hand. While we do that, we should also ensure that there is a reduction in the waste and emissions that are coming out of this production process. Circular economy is something that probably in the last 6 or 8 years, we would have seen it more in the market, even in the daily products that you're using. If you see at the labels in the packaging, you will see quite a lot of these definitions or a barcode implemented there, where if you scan a particular barcode, you can see the whole journey of a product, starting from the farm level till it comes onto the racks where you go and purchase these materials. So that is also one principle that has to be maintained when we talk about sustainable resources. Then the social and economic responsibility. More about this in the next slide. So I will now talk about the Sustainable Development Goals. So these are the 17 goals that have been defined by UN, which all manufacturers have, or it can be manufacturers, or it can be farmers, it can be anything which is coming out into the market, or even a process that you're simply following at a normal setup in your locations. these are the goals that we have to meet when we talk about ourselves being sustainable. One thing I would just want to highlight and point out here, now that all of you are part of this journey of sustainability and knowing more about sustainability, it is all of us together who will push towards achieving sustainability. It is not one manufacturer's responsibility or a one company's responsibility. In the daily activities that we are conducting, one or the other of these sustainable goals are something that we can definitely work on. So the 17 are about one. The first is no poverty, zero hunger, good health and well-being, quality education being provided to, it is not only the people in the upper strata, but also the farmers, if they have kids, they should also be enabled with quality education. Gender equality is something that is not 100% implemented probably in all the companies, but it's a work in progress, and it has a lot of detailing into it. Gender equality today, probably we don't have much time to discuss about it, but you can go back and read, and it's a very interesting concept and a sustainability goal. Clean water and sanitation then is also part of a manufacturing setup. Affordable and clean energy, decent work and economic growth. We will be talking about it more in this session today. Industry innovation infrastructure is also something which is part of manufacturing setup. Reduced inequalities is not entirely applicable in today's discussion. Sustainable cities and communities is, of course, it is on a larger aspect, which is more into governance. The governments and the institutions are more so responsible in ensuring the SDG 11 is met. Responsible consumption and production is where all of us together can make a difference. Responsible consumption is something that we can always ensure and take care of. And it is something that in our hands. We would have seen that people would want to, a simple act of repeating a particular apparel that you're using, or also not putting out a lot of things to waste, which would also mean that you're purchasing also lesser and just being responsible in your capacities. Climate action is something that is part of manufacturing setup. Life below water is different from what we are talking today. Life on land, peace, justice, and strong institutions is again a global governance initiative which has to be implemented. Partnerships for goals is every partnership that is between governments or companies or a group of companies coming together to achieve a particular goal. All of that falls under SDG 17. So today, the SDGs that matter for us in this discussion are 3, 6, 7, 8, 9, 12, and 13. And more about these. So first thing is SDG 3. So I'm going to define this and explain it to you, because you will then know why we do what we do in terms of manufacturing process. First thing is good health and well-being, to ensure healthy lives and promote the well-being for all people, all ages, who are part of the whole value chain. Integrating safety into the quality assurance minimizes risk to workers and consumers, and also reducing the workplace accidents. Clean water and sanitation is to ensure availability and sustainable management of water and sanitation. Quality assurance here will monitor and reduce the water consumption, which is the first step to ensure that we reduce the consumption of water and also the pollution during manufacturing. 7 is about affordable and clean energy, more so usage of renewable energy in the production setup. So one example I can give you is in a manufacturing facility, there are a lot of companies which still use fossil fuel run boilers. And if that is replaced with a solar equipped electrical boiler, then that is a big tick in terms of reducing the GHG emissions. So that is something that can be factored into the quality assurance system when a company can claim that they're being sustainable and responsible. SDG 8, it is about decent work and economic growth. Here it is two things. One is to ensure the workplace is safe for everybody working in the facility. It is not just the workers, but also the employees and other employers and even the management for that matter. While they do this, you should also ensure then that there is fair labor practices, and the economic situation of the workers is also taken care of. And that is where the technology of finance and all the other aspects can be included when you talk about integrating sustainability into a manufacturing setup. 9 is industry innovation and infrastructure. You would have already known from the other sessions the use of technology and of course, being in the industry that you are in, computer science and the tech that you've seen, there is quite a lot of innovation that is happening that can reduce a lot of incidents also, and also reduce emissions and make and design or define a more efficient system of manufacturing production. 12 is consumption and production again, to ensure the QA processes reduce waste, improve the resource efficiency, and promote circular economy. This then entails the recycling and reusing of materials. 13 is climate action. This is about reducing carbon footprint and also the emissions that I talked about while in the manufacturing process. I see a hand up.
Slides are not changing, Ankit.
I changed now.
No,
Is
it
it
is not.
changing?
No, it's not changing.
Oh, has it not been changing all this while?
No, still it is in the second slide from the starting.
Oh, let me just stop and reshare.
Yeah.
Is it changing now?
Yeah, seventh slide. Yes.
All right, thanks. So I think then you couldn't see all of these slides. So these are the sustainable goals that I was talking about, and the only relevant ones for us in this discussion are these sustainable goals. Just to bring things into perspective, I was at this slide wherein I was talking about the individual sustainability goal. The hand is still up. Is there a question? Okay, so this slide was what I was explaining about good health and well-being. SDG 3, SDG 6 about clean water, SDG 7 affordable and clean energy, SDG 8 is about the decent work, making workplaces safer. Industry innovation and infrastructure is about the new technology being implemented in industries and making the whole process effective and efficient. 12 is about responsible consumption and production, wherein we improve the resource efficiency, promote circular economy, and also recycling and reusing of the materials in production. It's not always that. So these days, we are also working on circularity, wherein a lot of, at least in the garment and the textile wastes, a lot of these wastes are now being reprocessed and taken back into manufacturing, and they don't go into the landfills, which will definitely reduce a lot of these wastages going back into the nature. Climate action is about reducing the carbon footprint and also minimizing emissions. So while we talk about carbon footprint, it is a lot of aspects, right? Even when we are using a laptop, even the heat generated from a laptop is also considered as an emission. And factories who have large setup, there is a lot of emissions that come out of there. That is also part of the carbon footprint. Then when you talk about farmers using pesticides and chemicals for growing the different crops that they do, which become the supply chain for manufacturing setup, even that also falls under a lot of emissions. The nitrogen oxide emission and a lot of other gases, those are also part of this. So it's not only about one particular manufacturing facility that is responsible for this. The entire value chain is then responsible to reduce the carbon footprint. Moving on to talking about how sustainability and QA now intersect. So I've defined what is quality assurance. I've also defined what is sustainability and what are the sustainable goals that we have. Now we have to intersect both of it into the modern ecosystem and see how best we can align and get the results that we are looking for. So in the current scenario, in the manufacturing ecosystems, sustainability and quality assurance are no longer considered as separate goals. We have to evolve to integrate the sustainability metrics, which I just now talked about, the emission, making people workplaces safer, and all of these definitions that we have, which is now integrated into the output metric, while we also check for quality in the manufacturing processes. Product and process quality will now include the environmental impacts also. QA teams now have to ensure that compliance with environmental standards are met. So I would just introduce one more concept here, that there is, apart from the ISOs and the ESGs that are defined, there is also EUDD, which is due diligence requirements, which is defined by the European Union, and most of the brands globally will always follow that directive. So due diligence is another factor in ESG implementation, which has multiple pointers, which has to be then met if I have to consider even procuring a particular product. Now you're seeing the whole tariff situation happening globally, and tariff is about the money and the taxation aspect, where due diligence also becomes a critical component for a country or a global company to decide if they want to procure a particular product from a manufacturer. So even in India, like I can talk about India's perspective, we have our own due diligence requirements, which is defined by the government. So when we talk about the compliance aspects of as a QA team, it is not enough if we are following an ISO. It is also important that we also then follow the due diligence requirements of the country as well. Last step is what I think all of you might know more about this than me. It is about the technology and the integration of technology in monitoring, optimizing both the quality and performance. So all of these, the programmings and the instruments which are used, I think all of you have pretty stronger knowledge than me about all of this. So all this put together is how you will then intersect sustainability and QA in the modern ecosystem. What then, and why are we talking about all this? Why am I saying that, sustainability is important, quality assurance is important? Why? And what are we trying to achieve, and what is the requirement or the expectation from the market? The first thing is that you have a holistic product integrity. Quality is not only about how the product looks or what is the duration for which the product works. It is also about how it is affecting a user or an environment. If I'm having a device in my hand which heats up quite a lot, then it's actually not sustainable. If I have a product which is going to not work for more than 1 year, then it is not sustainable. We've seen that the older products usually used to work for a longer time, and the new age products are not working for a longer time, which is actually a bad sign. But it is not only about how long that product remains, it is also about how it is affecting the environment also. And as a responsible consumer, it is also our responsibilities to ensure that we purchase products which are then sustainable in nature. Regulatory demands, this is a global demand which every other company these days will ask, and I can also tell you that go back to a couple of websites of the products that you're using on a daily basis. You will see that they have a lot of these sustainable goal declarations that they have, and their annual reports will carry all this information about how they have achieved the goal of being sustainable, or how they are meeting up to these requirements. Operational risk reduction, when the process is well defined, it is sustainable, then it is also going to lead to lesser accidents or lesser downtime. Lesser downtime, I always say, in any manufacturing facility, doesn't matter what kind of product you're manufacturing, having less downtime always means high production and high income. And if you have to have the least downtime, then you should have a very robust quality assurance system and a quality management system. Downtime means loss for any manufacturer, and for that only a predictive maintenance schedule can help to reduce downtime. So that is something that has to be aligned. The fourth is market and brand advantage. So I'm not sure if any of you would have seen this, but if you go to a particular apparel brand, you will see that a same product, the same design will be uh, uh, put up there in two different stands. One will be a completely sustainable product and one will not be a sustainable product. Lot of consumers these days have become smart and they're expecting that we need a product which is sustainable, wherein I know that I'm wearing a shirt today uh, uh, from a brand who has ensured that even the farmer who was growing the cotton has been taken care of. And when that happens, suddenly the brand has to maintain a lot of their consumers and also reach up to their expectations. And then those companies will have a broader advantage than the others. Anybody who is delivering a sustainable and a safe product today is trusted more, and they are relied more. With that, you will also feel that, okay, this is a company that I can go to, and that is enough for them to work more so on the sustainable goals to be achieved.
Ankit, excuse me, Ankit.
Yeah,
Still, slides are not changing. I think you have to enable entire share screen option.
one
Still, it is in a 7 slide only.
entire screen. Does it work now?
Yes, it's working now. Thank you.
Okay, sorry about that. So I hope it's things are clear till here. I was on this slide, wherein these are the four requirements that have to be worked on. So just a comparison, if you are currently aware about what is the traditional quality assurance system that is being followed till date and what is being expected with the sustainability driven quality assurance. Currently, the focus is only about product quality and the defects. You would have heard about Six Sigma, which broadly Motorola used to follow, and Toyota also follows still for a large extent, where the only importance was back then given to the product quality and the defects and also the longevity of the product. Out of every 6 lakh phones that used to be manufactured by Motorola, they used to ensure that only one of those used to have a defect, and that was the only quality assurance that what used to be followed traditionally. But now, sustainability driven QA also has to consider the environmental impact while they try and achieve a very strong, effective, efficient product. You can't be spending or burning a lot of materials to achieve a highly optimized product. You'll have to also cater to the environmental impact. Reactive inspection, so only when something was broken or something used to go bad, that is when the inspections used to happen. But currently, there is a whole proactive setup, predictive maintenance schedules and predictive inspections that have to happen, and also with the eco-conscious design. Earlier, it was a siloed process. There was no goal to be met. Anything that was defined internally by the management was what had to be catered to. But currently, it is integrated with the sustainability goals that I talked about at the beginning. And I'm sorry that you couldn't see those slides. The fourth is compliance based. So for an example, if I'm having a manufacturing facility in Karnataka, then I'm only looking at the compliances that I have to cater to the state government, and then the rest of the global compliances was not really taken care of. But currently, it is value driven and stakeholder oriented as well. So if I have to supply to 10 different brands, similar product, then I have to cater to the stakeholder who is asking for a couple of defined parameters to be met and the goals to be achieved. So embedding environmental sustainability into the whole process design is very important. Mitigating the safety risk, I will talk about this in detail in the last 8 or 10 slides towards the end of the presentation. Ensuring that the sourcing is ethical. So ethical sourcing is where I don't shunt a farmer or a raw material supplier and underpay them while they deserve to be paid at par with what the market is asking for. Or I am not swindling away materials for somewhere which is from unethical waste and then bringing it to the production as a raw material. So ethical sourcing is very important. You have to ensure that everybody is taken care of. The waste reduction has to happen and the energy efficiency, of course, has to be high. Product singularity, circularity, I have talked about it. It is about reuse. Basically, anything that is going back, if it is possible for you to reuse, then it is great. So one example that we have had in the state of Tamil Nadu, who used there is a system wherein the roads and the tar that they're laying, they try and use the electronic product waste as part of filling this up in the landfill. So that is also something which talks about circularity and reuse. Are the slides changing? Just to confirm, someone can confirm?
Yes, it's changing.
Okay, great, thanks. So the key principles now, when we talk about these basic principles based on which your whole designing has to be done. First thing is eco-friendly materials testing. Second is energy and resource efficiency audits to be conducted. Life cycle assessment to be done, wherein from point A to point C or D, how much ever steps you have, the whole life cycle is assessed. Closed loop quality feedback systems. It's not that you only implement something new, but you'll also have to take care that on a continuous improvement basis, the feedback comes back to the system and then you reinvent a lot of things to keep improving on a daily basis, or of course, there's a defined period for it. Sustainable supplier qualification. So globally, all products these days have that minimum qualification requirements that all of them have to meet. So if as a company I define 10 parameters, then unless a manufacturer falls into those 10 points, they will not qualify as a sustainable supplier for me. And that is something that has to be ensured while you're designing a sustainability driven quality assurance. So the first step here, while you're designing, you will have to choose not only for the performance, toxicity, recyclability, and worker safety. You can't be using a product which is toxic for the farmer and also toxic probably for the end user. So ensuring that while at the design stage, these kind of materials are completely taken out of the value chain. First step is to design that safe and sustainable raw material or a product. Second is data-driven decision making. Here is where we bring in the use of technology. We use Internet of Things, AI, and all the other latest technology that are available in the market to ensure that the quality, performance, and also the environmental impact is continuously optimized. Closed loop feedback. There are in the environmental audits that happen and the safety assessments that keep happening. So I can give you one example. There is one software, AI, it's partly AI, which is used by the ITC group. So there they have a system that if there is a risk that is identified in their process, they will continuously keep monitoring it over 15 days or a month or 2 months. And then when they gradually see that risk is getting mitigated, then they will reduce the risk level of that issue and then also ensure that this doesn't repeat in their other facilities or even the new facilities they are bringing in. So the closed loop feedback, what they've implemented in the system is definitely helping them to reduce a lot of incidents. So I was in a meeting with one of their management team and very interestingly, he told me that even a small gas that is emitted somewhere in their line, in the manufacturing lines, might look very small at the beginning, and but if somebody is exposed to that on a daily basis, then we get to know about it when we keep monitoring the health of the workers on a regular basis. So they identified one of these issues in their manufacturing plant is because of where they were also monitoring the health of the workers. Otherwise, they would have never identified there is some underlying issue in the whole process, right? So that kind of a closed loop feedback related system is very important when you want to have a very robust manufacturing facility. Cross-functional integration here is because it's when we talk about manufacturing system, or if we define someone as a supplier, they are always hounded by quite a lot of teams. There is an ESG team that comes and asks them that you need to follow the due diligence requirements. And then there is a EHS team that comes and asks for a lot of these safety aspects to be taken care of. Then there is an R&D team who is saying that this product can be enriched, it can be made better, or a new kind of product has to be developed, and a lot of those things come in. Then you have your buyer who will then ask for a lot of changes, yeah, or also ask you to increase the production or decrease the production. So all these teams have to collaborate together to ensure this, because if you try to do something extra for one team, that might hamper the metric of what is expected by the other teams. Cross-functional integration is very important, and that is how I'm sure any system or a setup, right? If you don't have that cross-functional integration, it is very difficult to have it going for a long time effectively and efficiently. I will now move on to the role of technology. So 4 components very necessary when we talk about secure implementation of QA: IoT sensors, AI and machine learning, digital twins, and blockchain. These are concepts that you are pretty much well aware about. I'm sure all of you know exactly how all this functions, and I might sound a little lame if I'm defining these things, so I will not go into defining the technology for you, but I will define how it is relevant and used in the kind of setup or a system that we are talking about. First is the IoT sensors. Collecting data and transmitting real-time data is a work of the IoT sensors. The key benefit with that is it enables the immediate detection. Any parameter which is different than what it should be, it is immediately detected and the data is brought out. Data-driven decision making is easy. If we have real-time data that is coming in, predictive maintenance again becomes easy. If I detect that there is a particular emission which is more than what is required, or for that matter, if I see that there is a temperature rise in one of the processors or one of the machines much before the incident happens, then it is easy to go and switch that off or address that issue, and that predictive maintenance becomes easy. Because if you were to let something break down, then the time taken to get back things into motion is going to be much longer than what you can achieve with a predictive maintenance setup. Remote access, it is already well known. The simplest remote access that in our daily lives that we've seen is that you can have the air conditioner switched on even before you go into your house. That's a simple tech. But using that in a manufacturing setup can be much more helpful, where anybody anywhere can control and monitor. So the used cases in right now in the market is for smart factories, wherein the emission is continuously monitored, urban air quality tracking. So this is where the whole aspect of the governance comes in. As a government or as an institution, if you have to deliver and also claim that you're taking enough steps to reduce GST emissions, then this kind of tracking is necessary for the governments. Precision agriculture, again, here is when I talked about at the agricultural level, the products that they use, the emissions that they generate, this becomes an important factor to ensure that. Water and soil quality. So you will be aware that a particular uh, produce grows in a particular quality of soil, and when you change the crop, then there is a change in the soil quality as well. Also, if there is a farmer who is not supposed to use a particular pesticide, and if they still go ahead and use it, then as a consumer or a manufacturer or a buyer, you can get to know that there is something that is changed or is different than what it should be, and it is easy for us to ensure that these kind of practices are also stopped. AI and machine learning, it is analysis, which is definitely required. It's not enough if I'm drawing data from the IoTs. If my machine is not learning, the system is not learning and reinventing, then there is no use of that data. So predictive quality control is achieved with this reduction of material waste. So if I'm seeing that I can reduce the consumption of water in a particular manufacturing process, then definitely this analysis is going to tell me that you can do with much less water consumption. And that is something that can be achieved as a sustainable goal. Continuous improvement, it keeps happening. There is no stoppage to learning. There is no stoppage to learning of AI as well. And there is no stoppage to a continuous improvement. Cost savings, all of these other aspects, when you're taking care of it, cost saving becomes a subset. Having reduced uh, downtime is definitely a cost saving for the management. So used cases here in this is defect prediction in assembly lines, which is something that has happened for a long time now. Smart sorting and recycling facilities. So just as an example, there are factories who also manufacture jeans. I'm giving a textile example. More of my examples will be textile because that's the industry that I'm primarily concentrated on. So there is a manufacturing facility who manufactures shirts. They also manufacture jeans. Then they also manufacture kids' clothing and all of it. All of these three products have different kind of materials that they use, and the waste that comes out of these products are very different. So sorting of this becomes easier with the use of technology. Earlier, the sorting was very difficult, and that's why they used to never sort. Nobody wanted to address that problem at all. They said we cannot sort this, we can't disintegrate this separately, so we put everything to waste. So that thing has now changed, and smart sorting has actually benefited, and we've reduced quite a lot of these wastage coming into the landfills. Optimized machine calibration is easier. I can have more efficient machines which will use less power to give us the optimum output that we've already been getting. Or probably if you have a fuel uh, run motor or a machinery, then reducing the fuel consumption but still meeting the requirements of manufacturing is also possible with calibration. Real-time adjustments in chemical or food processing again is much more easier. So the simple calculations that probably an Asian paint does when you have to generate a particular color, it then gives you the four different colors that has to be mixed and defined. Similarly, in a food processing industry, when the output in the manufacturing setup detects that there is an anomaly, then it will immediately readjust, and real-time adjustment is possible. Digital twin, the simplest example for me on a digital twin has always been from Formula One, wherein you have the simulations, wherein the whole designing of how a car can be faster and efficient is done on a simulation inside a manufacturing facility. So digital twin is just that. I simulate a particular setup and I see how I can achieve. So I simulate my whole manufacturing process and I see how best I can bring the optimum output. I can also make real world changes in that. I can do all kinds of trial and error in that system to see how best I can have a setup without actually having to run the whole machinery to realize what we are going to get. So with that, without a risk, optimization is possible. Faster decision making can happen. We don't really have to invest all of money to decide whether a particular manufacturing procedure is going to work or not. So that is going to make life much more easier. And life cycle impact analysis again is much easier to do. So used cases in the market currently is virtual testing of energy saving designs. Emission modeling, I've already talked about it. It is just like the emission that is checked in our cars, right? We have a couple of gases, and what is the percentage in the emission is all of that is got to us in that report. But we as car users don't do anything about it. But manufacturers can definitely work on reducing the emissions from their manufacturing setup. Waste stream analysis, again, same thing, reduce the chemicals which is sent out along with the effluents into the water stream. water and energy optimization is eventually possible with this. Blockchain traceability. So again, I will not, you can read the point by point here, but I have an example to give. So one of the very famous manufacturer, I will not name them, but one of the very famous companies, they have a system wherein all the safety implementations in the factory is all uh, designated with a barcode. And any employee in the factory, or if there are multiple 20-25 units spread across India, any employee can log in and see what is the status of the safety testing or all the reports and anything and everything about what they have. Now, blockchain here gives that kind of data transparency to all the stakeholders. I, as an employee, even if I'm a small limited wage worker, also can log in or check and see what all is being handled by the company and where the safety implementations are in place or not. All this can be tracked and traced. Second thing is, there are some dairy products, and I used to do a due diligence for one of dairy manufacturing company. There, the whole value chain had a robust setup wherein if I scan the barcode of the butter that I'm purchasing from that company, it will tell me that the milk used for production of this particular product has come from a village so and so much so that it will also tell me which cow's milk was used in this. And that is the level of data integration that has happened in the market currently. So every cow whose milk is being supplied into this company is geotagged. The health, it also has a health tracking band, which is of course a technology which is currently being used as a pilot. But like how we have the watches that we use to monitor the health, the same thing is done for the cattle. So the end user can also know what is the health of the cattle, or at the time when the milk was taken from the cows, and then the whole journey of where the milk was taken, how it was transported, where it was stored, and when this whole product was manufactured. So that is the kind of control and information that uh, brands and products are currently giving us, and all of that has been possible because of blockchain. We put that out. Nobody can change this information. Nobody can tamper with that information, and a fair trade practice can be followed. All brands are very proud and about this, and they will happily claim that we are giving the consumers end-to-end detail about how the whole manufacturing has happened, and that's the kind of control that consumers want these days. So once you start getting to know that the companies are responsible with the environment and the people, then definitely we'll start purchasing those products more, and that's at least enough uh, remuneration for the factories and manufacturing facilities to integrate this kind of a strong setup. I will now show a small video, which is from, yeah, I hope the audio is also,
Yes, yes, we can.
okay.
A simple tea bag. Every year, consumers use millions of them. All of Unilever's products, including tea bags, go on a journey before and after they are enjoyed by our consumers. We call this the value chain. It works like this. First, we get the raw materials. Then we make them into a product and deliver it to a shop. Then our consumers buy it, use it, and eventually throw it away. But each step in the value chain also has an impact on the environment. Here at Unilever, we want to reduce that impact and grow our business at the same time. The value chain lets us see where our biggest impacts are, so that we can focus our efforts. So for example, Unilever's hundreds of factories only add up to 3% of our total greenhouse gas footprint. Around 26% of our impact comes from suppliers when they produce raw materials, and around 68% comes from the millions of consumers when they enjoy our products. So, most of Unilever's impacts aren't our problem, right? Wrong. We want to reduce the impact of our products before they enter and after they have left our factories. We work as a team with our suppliers, customers, and our consumers to reduce the impact of our products. We have ambitious plans to grow our business, but growth at any cost is not an option. We want to work to help consumers enjoy our products and cut the environmental impact at the same time. Every day, thousands of suppliers help us make our products, and 2 billion people use them. The maths is pretty simple. If we get ourselves, each of our suppliers, customers and consumers to be a little more sustainable, these small actions will add up to a big difference. A really, really big difference.
Yeah, so the purpose that I wanted to show this is because all of us are equally responsible for reducing the emissions, or be it achieving sustainability for the companies. And you see that we have a small part to play as well, or rather in a bunch, we all play a very big part in companies achieving this. So with this intention, Unilever then actually devised their strategies on what has to be done and how do they change or reduce the impact that are having on the environmental. Okay, so the first thing is environmental management standards. So Unilever now employs that it has its own environmental care framework. With that, they have improved their manufacturing systems. They have also implemented steps wherein they reduce the waste, consume less energy, and also renewable energy has been added into their setup. Waste to landfill, zero waste mindset is something that has been implemented in all of their production sites, emphasizing that they reuse the materials that usually would have been wasted or being thrown out. So that is also something that they have implemented. Zero efficiency metrics, wherein Unilever continuously tracks the coefficiency indicators. This is where I said the continuous improvement process that they have implemented. And also now they have embedded the sustainability and safety into product development as well. With all of these things that they have done, since 2008, Unilever has actually cut carbon dioxide from 79% per ton of production, and that's a 11% reduction that they've achieved. Disposal of waste per ton of production has decreased by 96% since 2008. Also, water abstraction has fallen by 48% per ton of production. So these are pretty big numbers for a company at this scale that they're able to achieve. And also they've achieved 70% reduction in product related incidents. So the incident part, I will talk more about it in the upcoming slides. So the lessons that they've learned is sustainability and quality are mutually reinforcing. It's not only about what they do internally, they are also relying on their consumers also to be responsible. Systems and audits have definitely driven improvement in their setup in reducing accidents and incidents also. Mindset over mere metrics. One thing that everybody has to inculcate is the culture of being sustainable. It is not only about the process and all of that, but if you have your mindset strong enough to ensure that consciously I'm going to take these 1 or 2 steps, it will make a big difference in the long term. Aligning their investment with sustainable goals. So now they have made sure that they put the money where the mouth is, right? We want to achieve a particular sustainability goal, and any kind of investment that is going to help them achieve that, their investment is going only in that direction and not on things that don't matter in the broader spectrum. Also, the biggest lesson learned is technology amplifies impact. The technology that we have already talked about is significantly shown quite a lot of impact. So we have this case of Unilever who actually implemented all of the things that we discussed now over the last 18 slides and also shown that it is possible to achieve impact with this. Now I'll go to my last topic of SDG 8. This is about ensuring safety and fair labor. And this is only one subset of the whole broader spectrum. And I'm only doing a deep dive on ensuring safe working conditions. So I'm in your other sessions in these 4 or 5 days, I'm sure there are different concepts which will also that you have learned can be integrated in manufacturing setup. But ensuring safe working conditions is what I will now emphasize on. So ensuring safe working condition means that you have to safeguard the worker in a way that they are not prone to incidents or accidents inside the factory. So the major three components in that is fire, electrical, and structure safety to be implemented inside the factory premises. Promoting fair labor practices. So I'll give you a terminology that probably you can remember is there is technical compliance and then there is social compliance in the world of compliance. Technical compliance is what now I will be talking about, which is fire, electrical, structure safety, and all of it. And social compliance then talks about fair wages and responsible working hours to be given. Forced labor or a child labor shouldn't be there, and not of those social aspects that ensure the life safety of workers. Continuous improvement is also something that we have already talked quite a lot about, and strengthening the accountability is that can be achieved when you let a third party do all of the inspections or verifications in the factory. The thing is that, of course, no matter how robust a system that you have, you will always look at your facility with the much kinder eye than what a third party verification firm will do. So a lot of these companies have hired third party inspection teams who step into the manufacturing facility to verify if everything is in place or not. And this is definitely very important if you have to maintain accountability as a manufacturer in this day and age. So just a premise to you to bring things into perspective so that you will also understand why I am talking about safety being very important and why SDG 8 emphasizes on worker safety. So this is an example of the fashion industry. And maybe you would have heard about the incident called Rana Plaza. If you haven't heard about it, please write it down and go back and read about it. It is the incident at Rana Plaza in Bangladesh. So happened that there's a multi-story building which collapsed structurally with workers sitting inside and working in the setup. And this whole incident happened because there was no audit that was done or an inspection done in terms of structural safety to check if the workers are safe or not. And that is why the whole logic and system of worker safety and structure fire electrical safety was brought into perspective. You will see that I've just put up quite a lot of these incidents, fire incidents that have happened, which has led to a lot of deaths and also infrastructure damages. And in most cases, any fire incident, you go back and read about it, go open your newspaper or read about the last fire incident that has happened in a manufacturing setup, you will see that it was probably a short circuit or a spark, which could have easily been avoided in a setup. And that is how simple it is, yet how defining it is, which will change the whole spectrum of a life cycle of a factory. So implementing a robust safety management system or a safe system, first thing is dependent on standards and frameworks. ISO 45001 is the international standard which is followed for occupational health and safety management system. OHS is again it's the legacy standard 18001, which has always been followed internationally, and then there is the ILO guideline on OHS. An ILO guideline integrates quite a lot of these national guidelines also, and of course most of the countries adopt the guidelines given by ILO and implement that in the local level in all the manufacturing facilities. So implementation steps here, then the first step is to assess, audit, check what risks are there, what gaps are there in the setup or a system. Then you have to set the objective and also define a policy which says these are the steps that have to be taken in the factory, and these are the things that we'll continue to do. Involve all the employees in planning and execution. It's not enough if you have a safety mechanism in the factory and your employees are unaware about what setup has been done. Even for a simple firefighting equipment to be used for their own safety, if they are not trained to use it, And if they're not aware about when to use it, then there is no use of having it in the setup. So training the employees and educating all of them and empowering them with that information is very important. Monitoring the performances with audits and KPIs. It is a new trend that is being followed, that the safety managers are given KPIs that they have to deliver to, so that the whole sustainability aspect of safety is maintained. Again, continuous improvement. This you will see anybody talking about sustainability will always talk about continuous improvement and feedback loops. So briefly, I will give you an idea about how an audit or what are the aspects that audits in manufacturing facilities in terms of sustainability follow now. So when you go for a structure safety or an assessment, it usually the things that they check is how the grid spacing is done. If there is a drawing, then according to the drawing, are the construction materials used safe and secure? What kind of construction and what year it was constructed? They will check the wall for thickness. They will see if the structural loading is more in a particular pillar or a column. There is also, they will do a check on cracks if it is there on the surface of the wall. So these are all the checks that are done in a building in terms of structural safety. There are two instruments that are generally used, which is one called as a Smith hammer and also ferro scanner. Smith hammer is used to check if the compressive strength of the concrete is strong enough. So usually these audits are done in a building which is probably 10, 15 or 20 years old. And with age, the building also deteriorates, and checking this is very important. Ferro scanners is a device that is used to which will scan and tell you how many rebars are used inside a column. It is a very interesting device. Maybe you can look it up on YouTube. Just if you're curious to see how that machine works, you can see that is very important to identify the number of rebars or the diameter and size of concrete that is placed over in a pillar. Fire safety, you would have seen or heard about this quite a lot, even in the college that you are in or wherever you go, even you go for a mall, keep an eye out. You will see these signs. You will also see the evacuation maps written. You would have been provided a proper evacuation path. All of that is defined in your daily life. You will actually see all of these things around you. It is not just manufacturing setup, but anywhere and everywhere. It is good for you to have an idea of whenever you go to a mall or a movie theater. First thing is that you identify where your exits are. You never know when there is going to be an incident, and this kind of information is very important for you to be aware about where to escape. So these things are usually checked in a factory. The evacuation paths in manufacturing facilities are usually blocked. Somebody is bringing in a material, they forget to take it back, and it is kept on the evacuation route. And if supposedly if there is an incident, then people can't evacuate freely because there is a blockage in an evacuation. And that is why it is very critical and important that these kind of factors about the width of an exit, the temporary obstacles not being in place, the firefighting equipment having to be maintained properly, the fire pumps have to be maintained properly. And for all of these things, you can use the IoTs. Even you can see if the water pressure gauge is working or not. And all of this can be integrated into a software which will give you a heads up if any of these parameters are not functioning properly. And that is how you can integrate the whole technology piece into a sustainable activity inside a factory setup. And also one fact is people in a fire incident don't die because of the fire, but because of inhaling the smoke, right? And there you will see how important then it is to evacuate people within 2 minutes of an incident happening. So the general rule is no matter how big your manufacturing facility is, people should be able to evacuate from that premises within 2.5 minutes. And that's the rule that is followed. And to ensure that there is regular fire drills that have to be conducted, all of these metrics have to be logged on a regular basis. You will have OHS committees in the factories who will have been entrusted with the responsibility to maintain this. The other test that I mentioned is periodic test that has to be conducted to check if all the systems are working fine. Electrical safety, the most important issue that comes up in manufacturing units is the high temperature in electrical panels, which is not visible to the naked eye. Nobody will know if a temperature at a particular electrical junction has gone up to 200 degrees and suddenly it sparks or it burns, and that is when the whole incident happens. And this is where it is very important to monitor the temperatures in the electrical panels. Having a temperature sensing device in all of the panels will give a fair idea about how your systems are functioning. Also, these days, there is quite a lot of technology that is being used, and one general fact I will give to all of you is the permissible temperature rise for an electrical device, wherever it can be even in your houses, is just 20 degrees above the ambient. And in my experience, when I visited factories and the auditor is doing a temperature check, I have seen in 95% cases that the factories have electrical panels and some of the junctions having a temperature of 100, 120, and in a worst case, I have seen a 240-degree temperature rise, which is 200 degrees above the maximum permissible level. And this is a risk which is sitting inside the panel with nobody knowing about it. And this risk can be easily mitigated with the use of technology and regular monitoring. You can also identify if over a course of 3 months, if a particular junction has a 2 degree or a 5 degree temperature rise periodically when you have checked it, then it is easy for you to identify that that junction is going to fail someday, and that's a predictive analysis that can be enabled with this. So these are a list of documentations that are usually checked, and again, all of this can be put into a software or a system and regularly maintained with a record keeping and the maintenance record keeping. I will talk about that checklist in the next slide. So briefly, without taking much time or diving deep, I'll give the last 10 minutes for question and answers if there is any. So safety management system is very important in integration and achieving the sustainable goal 8. Safety management system has 4 quadrants: safety policy, safety assurance, safety promotion, and safety risk management. First thing is to define a guideline, have a management commitment, and also put a structure in place which will say these are the things that we are going to follow as a system inside the factory premises. Once you have defined the policy, then the next step is to ensure that the policy is being implemented effectively across the setup. That is where the whole quality assurance piece comes up. And also then you'll have to identify the hazards. Hazard doesn't stop at one step. Today, when you start a setup, you have a particular hazard. 6 months down the line, you will have a new hazard. When the machine is probably 6 months old, it will have a new issue. So defining these hazards on a regular basis is also very important, and of course, addressing them is important. Safety promotion is where you train the employees. The culture of safety has to be implemented. Also, there are some manufacturing facilities who have regular events or quiz which is conducted for the workers just to keep them interested in learning more and more about safety. Then it is about safety risk management. Putting in place a lot of controls is important, but also uh, time and again, it is important that you check if these controls are adequate and if you need new controls to be implemented in the system. So this is where the whole AI and technology piece also can be integrated, wherein having a robust safety management system is only possible if you have all the components that I talked about with the use of technology before these slides or the earlier slides. So implementation will have these important components: safety audit, safety KPI being defined, safety assurance being implemented, data analysis on a periodic basis or on a daily basis, very important to see how your setup is functioning. If a particular machinery is misbehaving, it can lead to an accident or an incident for a worker. And it is very important to have a detailed analysis from the data that is coming out of these machines to know if something is going to go wrong. And data analysis becomes very important. Incident investigation again. A small example is in garment industries, you see that there is a needle problem sometimes that the workers complain that the needle is pricking them. It seems or looks like it is a small incident, but then if it happens to 5 workers, then you know that there needs to be something that has to be put in place so that it doesn't repeat. Either you give them PPE so that they don't hurt their hands, or you change the whole system how you're manufacturing that product so that you can reduce these accidents or incidents. Incident investigation is very important. It always has 2 components: to record an incident, but then also to act and close that incident becomes very important. Checklist, hundreds of checklists are used now currently in a very manual fashion by the factories, and they've still not adopted technology in a lot of facilities that I've seen in India or even globally. But slowly, of course, everybody is going into softwares, and the best part about using software here with checklists is it pops up and gives you reminders when a particular machine has to go in for periodic maintenance. It is easy for workers in a manual setup to lose track of when a particular machine was last inspected or taken out for maintenance. Use of technology makes it much easier. All the timelines get defined. Something has to be checked by the end of 3 months. You have a reminder or a pop-up. Something at the end of 6 months or 1 year, you have a pop-up. When you integrate all the devices and machines into the software, anything that is malfunctioning, you get a indicator that something is not there. Simplest of the simplest things like a fire exit light. If in case there is an incident or a fire in a factory during the night time, then the first thing that happens is the whole lights are cut off or the electricity is cut off. And at that time, the fire alarm system and the fire exit lights, which work on their individual capacity with the batteries, becomes very important for people to evacuate. In the daytime, when you look at an exit sign, it looks like just another plate or a device, right? But it becomes very critical in the case of an incident or an accident. And use of technology here will help in achieving this very efficient setup of fire safety as well. So all of these factors become a integral part of the whole setup. Checklist, I think I will be sharing this deck with the team. Maybe you can use this deck again or go back to read this. Setting a policy, and that is where you will define the checklist. There will be different factory will have different checklists. If I have a product where I'm only manufacturing water bottles, then my checklist will look different. It is not a one size fits all kind of a setup. It has to be stitched to each facility's requirement and demand. And having these different parameters in place while defining the checklist becomes very important. So the biggest impact on workers and operation is lower injury rates, enhanced physical and mental well-being. I've personally I can vouch for one thing. All the workers that I keep talking to whenever I visited in all the countries that I've gone to, they are much more happier when they know that the factory has a well-maintained safety setup, and that matters to them in their mental well-being, because they go back home to a lot of other problems in their personal lives or whatever that is. But giving them this, ensuring that they're safe in the place that they're working is one thing, is good for retention, but also is good for physical and mental well-being. And the empowering them with trainings and participation is when you give them more knowledge about these things, they feel empowered. Benefit for the operation is having reduced downtime, greater income, good reputation. More brands will be willing to work with this manufacturing setup. And with the sustainable goal alignment also, you can achieve decent work, you can have inclusive and safe workplace, and then also contribute to sustainable economic growth. And with this, you can easily declare to the brand or even at the governance level that SDG 8 is being taken care of in the manufacturing setup. Overall, apart from the SDG 8, to all the general topics that I've talked about, the standout benefits in a sustainability driven quality assurance setup is reduced environmental footprint, Cost reduction we've talked about. Better compliance and regulatory risk is you will be pretty much catering to every compliance requirement which is there globally. Increase customer satisfaction and trust. Even as a consumer, you will definitely be much more happier if you know that a manufacturing setup is following all of these parameters. Future proofing of the manufacturing process is also easy. But the biggest challenge right now in the market is the high cost of implementation of technology. Also, then there are a lot of people who say my system is functioning the way it is functioning, it is good and easy for us. We don't want to adopt new systems or setup. And that's a radical change of thinking that has to happen, which will definitely happen, but there is quite a lot of resistance that we've seen in the market over a period of time. The skill gaps and the lack of sustainable QA training. Uh, See, this definitely is a pretty vast subject right now, and quite a lot of these concepts have and people will have to have a lot of skill while implementing it. When we talk about it in a very bookish way, we see that okay, these are general parameters that has to be maintained, but when you go to the ground level to implement, then there is a lack of skill and the gap of understanding that is seen in setup, and also because factories don't invest uh, in resources who are well qualified to do that job for them. So that is something that has to change. And also the supply chain complexity. It's not easy, even if it is a small paper cup, it is pretty complex to source the material, to ensure that the farmers or the workers there are safe, and to also build that whole value chain. It is complicated until the time that you achieve it. So that also is currently being looked into and addressed at bits and pieces wherever it is possible. The future, the trends that will shape this whole concept of pushing quality assurance with sustainability, circular economy, durability, reusability, and recyclability is something that has to be done. Material traceability, I'm sure all of you will be curious to go back and see which are the products that are traceable. You will have get your hands on a couple of things in your houses also, with which you can check the material traceability also. QA validates the compliance. Eco labels are, again, there are many labels that different brands use. And all of that has to be catered. If someone has to cater to all of that, then this QA aspect comes into picture, because QA is where the whole vetting of this activity happens. When the QA says that yes, you are achieving this, only then can the brands claim with their eco labels that they have achieved all of that. Carbon neutral production goals. This is a global aspect. Emission tracking is something that is mindfully done by governments as well. Accuracy of the carbon offset and reduction claims, if the manufacturer or brand has to do, then it's the QA team who will have to give that information out back to them. Efficient processing and meeting the quality standards on a regular basis is also only possible if the quality assurance is integrated. Industry 5.0 is the future. It's where the human-centric and sustainable manufacturing will be followed, which will also blend the AI with, of course, the human aspect. It's not that completely AI can handle all of it. Human expertise is always definitely needed. Hyper-personalized production and ethically safe, sustainable outcomes is possible, and real-time quality control, which I've already talked about in detail with AI, is possible. But again, sustainable quality assurance can help you achieve all of this. As a conclusion, I will end at this and open out the floor last 5 minutes for questions. Sustainability and quality, we started with this point and we're ending at this point. It is converging. It is not two different paths to be followed. It will always in the future converge, and it is two peas in a pod, if I can simply put that out. Evolving QA to this today, if I'm putting a QA system in place, that's not enough. Next year, there will be something new, something better. And my system should be able to adapt to all of those changes and the goals that is expected out of the manufacturing system. Tangible benefits for early adopters is already seen. Companies who have already started integrating and measuring these ROI are people who are in the lead, even before the EU due diligence could come out. And also there is one more which is going to come out by the end of 2027 or 2028, which will be a lighter version of the current EU DD, which was defined, which was pretty harsh. But when with those coming in place, any manufacturing setup who has already adopted these will be in a better position to declare their numbers. So I would finish at one last point that sustainable quality is not a cost, but it is definitely a competitive advantage and also a responsible step to be taken by manufacturing facilities. With that, I'll open out for questions if there are any.
Dear participants, any queries?
Or if there's something that you probably think about or if something comes to mind, that this is my email ID, you can always reach out and I'll be happy to answer questions. Is there any question on the chat?
No, there are no questions on the chat. You can raise your hand or you can write it on a chat box. There are no questions.
Okay.
Okay, thank you, Ankit, for the wonderful session. On behalf of the organizing team and all the participants, I extend our heartfelt gratitude for delivering such an enlightening and thought provoking session. We sincerely thank you for sharing your valuable insights on sustainable development goals. Your session inspired us to think beyond conventional approaches, reminding us that sustainability is not just a compliance requirement but a strategic pathway to resilience, efficiency, and a long term growth. We truly appreciate the time, effort, and expertise you shared with us today. Your guidance has been truly inspiring, and we look forward to translating these learnings into our professional practices. Thank you once again for engaging the session and inspiring on sustainable development goals. Thank you, Ankit.
Thank you so much for having me. And I'll also share the deck with you. Probably you can share it forward to all the participants. And thank you for giving me the time. And I hope I've done justice in the 1.5 hours to explain the concept.
Yeah, sure. Thank you, Ankit.
Thank you so much. Have a nice evening.
Thank you. Now, moving on to the next session on AI for energy optimization by Mr. Harsha Srinivas, I kindly request Dr. Vidya Y, Associate Professor, Department of CSE, to introduce our guest to the gathering. Over to you, ma'am.
Thank you, ma'am. It is our privilege to welcome Mr. Harsha Srinivas, a dynamic technologist who is at the forefront of IoT, AI, Industry 4.0 innovations. He's
Vidya, ma'am, 1 second. Harsha, sir, have you joined? Still, it is loading.
fine. Let me wait for them.
Another 5 minutes, yes.
Yeah, sure, ma'am.
Harsha, sir, are you there?
Yeah, I'm there.
Okay, fine. Vidya, ma'am?
Yes, ma'am. Shall I proceed?
Yes, ma'am, yes, ma'am.
Okay, thank you, ma'am. It is our privilege to welcome Mr. Harsha Srinivas, a dynamic technologist who is at the forefront of IoT, AI, and Industry 4.0 innovations. He is currently associated with Vignan Labs, where he leads several pioneering initiatives in AI-driven solutions while championing sustainability through technology. One of his remarkable contributions is Mysore.ai, a first of its kind platform that promotes sovereign and sustainable AI from India. In addition to this, Mr. Harsha heads AIMLware, an IoT startup based in Mysuru, which focuses on AI-enabled energy management solutions using Edge AI. Under his leadership, AIMLware is working towards integrating smart technologies with sustainability, with a special emphasis on solutions for modern factories and industrial applications. Mr. Harsha holds a master degree in computer science from Manipal University and brings with him over 4 years of diverse industry experience across AI, IoT, cloud computing, healthcare, and automotive sector. His hands-on expertise and innovative approach have allowed him to build solutions that bridge the gap between emerging technologies and real-world industrial needs. Beyond his professional journey, Mr. Harsha is deeply passionate about technology and automobiles. He also dedicates time to mentoring and conducting workshops for students and young professionals, sharing his knowledge on IoT, cloud, and entrepreneurship. So, we are honored to have him with us today, and we look forward to his insights, experiences, and vision. A warm welcome to you, sir. So, with that, I hand it over to Mr. Harsha Srinivas.
Thank you, ma'am. Thanks for the introduction. Right. So I'll go ahead and share my presentation. Just let me know when it's visible.
Yes,
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 sir.
it's visible.
Okay. Yeah. So first of all, welcome everybody to this session. I know that it's been a long day for everyone. It's been continuous sessions, right? But we want to keep this as a continuation of what has been happening around AI sustainability and the sustainable development goals, right? So today's this session is going to be on how do you use AI for the real sustainability in terms of energy, right? How do you optimize energy using AI? So here are some things that we will go through in the next 90 minutes. That's about where artificial intelligence plays a role in transforming how we work with energy, how do we manage energy and bring in efficiency, right? How is the concept of AI from IT going and touching energy that affects every other sector in industry today, right? And what do sustainable development goals mean? Whatever is defined by UN, what are those goals and how they impact this initiative of AI coming in here? And then we'll also look at some real world applications on what are possibilities, what are being done across the globe. And of course, me being from Vigyan Labs, we've been pioneering in this space for the past 15 years. So I'll also walk you through what we have done and how we've been using AI for the past 12, 13 years for the same cause. Please feel free to stop me in case you have any questions. We can keep this interactive. So the first thing that we need to understand before we talk about AI and energy is what is the need for doing this, right? And why AI matters in doing this. If you look at the general assumption of the public, it says that sectors like aerospace, mechanical, traditional industries are the ones that consume a lot of power and energy globally. But the truth is far from that. It's the IT world that actually consumes more than the aerospace world does, right? And with AI coming in, that number is just skyrocketing up. You may have read news from across the globe. People used to set up data centers near the North Pole in the Atlantic, Arctic region because it's cooler. You don't have to spend so much money and cooling energy on the servers. But that's actually creating a bigger climate risk at those areas, resulting in a lot of ice caps melting. So much that all the countries there are now asking companies to remove data centers and move away from that region, right? Same way on the other side of the globe, if you look at America, Facebook, Grok, Elon Musk, everybody is building massive data centers because they realize the potential of AI and the need for AI, right? Which means there is going to be a need for a lot of compute that comes in. But what is it, actually, what is the impact at the ground, right? Data centers traditionally require a lot of water and power for cooling, and they require clean water, which, as all of you understand, is actually a scarcity globally. So what this is doing is, because this generates so much data, our financial institutions, our entire country's backbone, or the world's backbone, global economies run on technology today, governments are promising clean water to these data centers, right? So what this is doing is, this is actually giving out the polluted and wasted, untreated water for drinking and for very primary uses, right? So this is a very challenging and terrible scenario that we've put ourselves in. But that does not mean that we have to stop using technology, right? We'll only be moving back in time. We'll be moving back a couple of ages back towards the Stone Age instead of progressing as humanity does. So what is it that we can do? What we can do is, obviously, we will not stop embracing and adopting technology, but we can find ways in which we can make technology not so expensive on our environment, not so power hungry, right? And that is the global energy need and the challenge that we have today in front of us, on why we need to optimize energy, make it smarter, right? Just to draw parallels, right? The human brain is capable of immense compute, right? Happens in less than milliseconds. But we consume less power than a typical smartphone today, right? So that means that there is a way to get to such a high power, high compute uh, infrastructure without consuming so much energy. So, and that is only possible if we keep progressing and we keep doing more innovations and discoveries in this space, right? Yeah. And the next thing is, before we get into the whole thing, is what are the SDGs that actually come into this picture, right? So I've identified 3 different goals, right? SDGs 7, which is about clean and affordable energy. How do you make sure everybody, every home, every office, every institution is getting very clean, reliable energy that does not come from fossil fuels, right? So that's about adopting a lot of renewable energy sources and also ensuring there are no losses and wastages in this. The next SDG 13 is about bringing in climate change, right? How do you reduce the carbon impact, the carbon emissions that are caused by traditional ways of generating energy and using energy as well. And of course, the SDG 12 is something that applies to all of us at any point in our life, right? It is a social responsibility that is put upon us. How do we ensure the energy that we consume is justified? We don't waste it. We, from a very young age, we've been taught that shouldn't waste water because it's a scarcity. Energy is equally important as water, right? So we have to continue to spread that message that we should not be using so much uh, energy the way we do. We keep lights on, we keep buying newer, bigger televisions, air conditioning systems, and refrigerators. But all of this is coming back and hurting us in ways that we don't see today. Now, what is the role of AI in this whole process. We've been looking at what really matters to, get into energy optimization, right? A traditional approach in the industry has been that you do an audit, right? You go through every equipment, every power line, everything that is there, every machinery, and understand for a couple of periods how much is it being utilized? Is it left on even when it's not utilized? If so, how much power is it doing? Who uses it? What the day? What and different variables come into play. Say, if I solve this answer to how do I save energy? That's been the traditional approach. And also some people have taken more strict rules saying, I'm going to schedule them. I'm going to turn off all the lights at 11 p.m., right? Some more people have gone into even more rudimentary methods saying, go around, check what lights are on, what fans are running, what computers are left on, turn them off if nobody is there. These are definitely a step in the right direction, but that's not enough, right? Because with 8 billion people across the globe, how much? Less than 1%, less than 0.1% of the people who are actually taking this upon themselves as a responsibility and doing this action, right? What about the rest 99.99%? They are undoing the goodness done by these people. And that's where, things like automation systems and technology comes into play, where it says, let me do this instead of being dependent on some human, right? Now, what is the data and what is the premises on which technology is going to do that? That is where AI comes into play, right? It can identify if there are any issues, any power wastage is happening. It can take decisions on itself, saying, I know that there's nobody in this room. Why should I keep my air conditioning on? Let me turn it off, right? It can also go ahead and predict, saying, I know this person in cabin A logs out and goes home at 6:30 every day, right, from Monday to Friday, and does not work on weekends. So let me create a custom rule or a custom, algorithm for him, which says, turn off lights, turn off the fans, turn off the AC, and put his computers to, shut down and hibernate at 6:30 every day, and don't turn on anything on Saturday and Sunday, right? So that kind of smart intuitiveness is what AI brings into this whole energy optimization game. There's also been a lot of techniques. If you go try to dig a little deeper into these AI techniques and energy optimizations that are done, people have done this in multiple ways. It can be anything from as simple as just predicting and telling people how much are you going to spend next month, when are the times at which you can turn off air conditioning systems or lights or any equipment. Sorry. Yeah. And or it can be something as simple as correlating weather data to telling you, do you really need to turn on the air conditioning today, or is it going to be more efficient and definitely healthier if you just open the windows and let fresh air come in, right? So that's what machine learning has brought into this whole dimension. At the same time, there are a lot of patterns and uh, you know every human dependent behavioral impacts that also affect AI and energy optimization. Like I was saying, right, in the previous example, this person A in cabin 1 that goes off at 6:30. There might be another person who has an earlier shift. They log out at 3 o'clock or 4 o'clock, right? So what systems can do is they can continuously be looking at all of this data and keep learning, right? So this kind of reinforcement learning and relearning actually helps build more optimized strategies over time, right? So it understands when it makes a mistake and it knows to correct itself to ensure that it doesn't do the same mistake again. So it's like a baby learning to walk. It is going to fall 1 or 2 times, but eventually it's going to start walking, right? And then there are other more critical and on the other side of things is how do I now ensure when I am using power, I don't use so much power. How do I reduce it, right? One is not using by turning off things and knowing when to do that. The other thing is when I am using, how do I use less? How do I make sure what I'm using is completely and efficiently utilized? That's where algorithms, edge AI algorithms, and anomaly detection systems come into play. They can identify when, let's say, you're using 100 watts of energy. Are you converting all of that 100 watts into power, into usable power, or is something getting wasted in the form of heat or any other form of energy, right? These are all wastages that are going through. So edge AI systems that run anomaly detection and reinforcement learning on devices such as mobile phones, laptops, IoT systems can actually learn these, identify these issues through simple machine learning, small neural network systems, and actually start taking corrective actions, right? These are some things that have to be applied across the spectrum. It is not saying this is only for industries, this is only for homes. No, it is for the entire power grid that is across the nation, across the globe, actually. So it's only when every edge, every end of this um, power grid is optimized through AI is when it actually builds to a scalable and a significant amount of energy optimization. Yeah. So, like I was saying, where are the areas that you can start with in where there is significant energy consumption and AI will play a very good role in ensuring there is sufficient impact to this, right? At a large level, it is the grids and smart cities. Uh, and I'm sure a lot of you have read about smart cities. So a lot of cities have been identified in India which are adopting these AI-driven and smarter technology that are actually driving them towards being more cleaner, more sustainable as a city itself, right? Which may include things like scheduled lighting, solar-based lighting, or some states like, for example, in the Northeast, a lot of street lights are actually driven by solar. Now, solar is not a very reliable power source in those regions because of the weather patterns there. But what they've done is they've used AI and technology to understand when how much power will be generated at what time of the year, and when how do you optimize the cycles for turning on turning off lights, and can you put these lights in like a dimmer mode, right? So that they don't consume as much energy when nobody is walking there, nobody's on the street, right? So a lot of such smarter initiatives have come into play to actually um, ensure we are making our cities, our people, and everything sustainable. Of course, the major two chunks where it matters a lot more is manufacturing and data center. How do we work on using data and AI to ensure there is less power consumed to manufacture something and to process all of that data in data centers, which is basically looking at usage patterns, predictive maintenance, and analytics through machine learning for ensuring there is less downtime and less energy consumption by like CNC machines, heavy heating devices, and cooling devices on the other side for data centers. So data centers is two things. One is reducing the cooling power consumed by cooling. The second is making sure so much heat is not generated, right? So if there's not much heat generated by the servers, then you don't have to cool it so much, which makes sure you have a reduced PUE. So PUE stands for power utilization efficiency, which in very simple words defines that if you spend 100 watts of energy on powering your server, how much energy is spent on cooling that server? So globally, if you look at it, for companies, they spend about 100 watts on powering one server and spend about 50 to 60 watts on cooling that, which puts your PUE at 1.6. That means more than 50-60% of the energy is spent in cooling that than actually running and doing the critical workload, right? So at Vigyan Labs, we've been working on optimizing that side of things, right? And I'm happy to say that we have brought that down from 50-60 watts to 15 to 20 watts today, right? So we're saying that you need only 10 to 20% extra energy to do the same amount of work. Thereby, we are not figuring out how to make air conditioning systems more efficient, but we're saying that air conditioning systems can become redundant eventually, right? Which brings in a huge impact to the energy globally. I mean, there are a lot more examples and sectors that can, that have to adapt this, starting from homes as well. Homes, educational institutes, shopping malls, and all of them, but I've just listed out some very critical spaces. Right. Yeah. Coming back to the whole data centers and IT, right? I heard that a lot of this, the crowd here today is from, computer science and IT background. So I wanted to keep this a little more relatable to them, right? The computers, the phones that we use, right? Everybody, all of us use phones, tablets, laptops, TVs, smart TVs today. All of this is IT infrastructure where we noticed something about 10, 12 years back saying a lot of these systems are just left idle even when people are not using. Right? Trends are changing, but a decade ago, this is not how it was. People would just turn on their computer at work and get up and go for their lunch break, their coffee break, snack breaks, and the computer would still be running, right? And that, if you look at a global number, that said 70% of the time it was left idle. There were a lot of people who would just leave it running throughout the night, throughout the weekend. That's about 2-3 days of idleness. And we did some math, and this said that annually one computer, if it's left idle for so much 70% of the time, approximately wastes about $100. $100 is about 9,000 rupees today, but this was a decade ago, so that was about 5,000 rupees back then. Even that is a significantly high number for one computer, right? And so if you look at this data, extrapolate this for companies with tens of thousands and hundreds of thousands of such computers left, companies are burning over $1 million yearly on just such ignorance by people, right? And this is not only about money, it's a lot bigger and beyond that. It's about the impact that is happening to the globe, to the climate, and to nature, right? So what did we what did we do to actually solve this problem was we said we will use AI. AI was not a big enough term. We didn't coin it as AI back then, but we said we will find a way to intelligently manage power for these companies. So we spent about 5 years doing a lot of research into core mathematics and computer technologies, right? Right from hardware to software, and then AI, was not what we know it today. It was glorified mathematics, right? It still is. And the reason we stuck to doing a lot of mathematics and theoretical equations was we had one simple goal. If we're going to be talking about sustainability and doing something for sustainability, for energy savings, then what I make cannot consume more power than it saves. If it does, then it beats the whole purpose, right? And even a decade ago, right, 15 years ago, running any kind of AI complex algorithm meant that you needed a GPU, a graphics unit, which all of us know today is extremely power hungry, heats up a lot. Now, if I want to run a AI unit, a AI algorithm with a GPU, that consumes so much power, more than what I save, right? Then it defeats the purpose. And that's where maths came to our help. It showed us that you can build complex mathematical models that can run on CPU, on phones, on very low power, efficient devices, and still take enough actions to save power. In the last 15 years has been on how do we improve that to bring in more energy. And I'm happy to say that today we have translated that whole technology on sustainable IT into sustainable data centers. Right? So we've proven that without using water, without using megawatts, and still using just kilowatts and few units of energy every day, you can run a complex infrastructure as big as UPI or SBI Bank in India, right? And how did we do this? And how did AI come into play into doing this, right? Our tool was called Intelligent Power Management Plus. So a lot of AI profiles and AI usage patterns are actually built into this system. And they also have, obviously it comprises of a lot of enterprise grade capability like centralized management, a lot of data analytics, and also a system design, which is something core key that every new technology and application that is built has to take into consideration. We cannot keep building applications that says, if I have to serve 1 million users, I'm going to need 1,000 servers, right? That is in no term sustainable. So what IPM Plus helped us prove that is, even if I'm going to serve 300,000, 500,000 users, I'm still going to use only one server, thereby making it one of the most efficient systems in the world today, right? So if I want to take you guys a little deeper on how AI has been used in this whole premise here, right? So our AI is actually called PowerMind, right? It's like showing that energy or power has a mind, which is AI. Right? That's how the term was coined. So what does it do? It actually sits as a small light program on every computer, every laptop, every desktop, Windows, Linux, Mac machine, anything, and starts gathering data on what did you do, what application did you use, is your screen on, what time is it on, from 10 o'clock to 12 o'clock, when do you take a break, when is your computer idle, when do you put it to shutdown, when do you hibernate, or when do you put it to standby. All of these different patterns it looks at. It also looks at what applications are running and how much power are they consuming, right? All of this without any additional hardware, it is able to collect and learn on the device itself without talking to any centralized system, without any server. It actually learns on the device itself, saying, now I know that this person is going to take a break at 1 o'clock. Every day he's been doing that for the past 15 days. So why don't I just keep a buffer of 5 minutes or 3 minutes and turn off his system, turn off his monitor at takes a break at 1:30, so let me do it at 1:40. And then as it continues to learn, it'll then start saying, okay, he comes back only at 2:30, right? Why should I only keep the screen off? Let me
Excuse
put
me.
it on standby. Yeah,
Hello, sir.
yeah.
Slide is not visible.
So I will reshare.
Sure.
How about now?
Still, now it is visible.
Okay, okay. Yeah. So as I was saying, now PowerMind learns and forecasts saying when is this person going to take a break? How long are they going to take a break? How long have they been taking a break? And decides that, instead of just turning off the screen, why don't I go to a standby mode for that 1 hour? It is going to save a lot more power, right? So it keeps doing this in a continuous loop and learning over time on the device itself, so that every person, because they have different behaviors, different working patterns, and different loads of work, it has to be a system that runs on their device and creates a hyper personalized algorithm for each one. So that's how we've used AI into building something that actually saves up to 50% power in laptops and desktops today, right? And we've been able to do this on scale to show to the world that you can also adopt AI for this kind of uh, energy efficient systems. And one of the largest global financial institutions, which is SBI, actually has deployed this and has been using for the past 7 years across 3 lakh computers, every ATM, every branch, every teller machine that you have in SBI across the country uses this system, and they have saved over 100 gigawatts of power till today, right? And what does that mean to SBI? That means they've saved tens of thousands of tons in terms of CO2, and also 100 crore worth of money just by implementing one small AI system across all their computers and servers today. Now, coming back to how this whole concept of using AI links back to the SDG goals, right? So, like I said, you can use AI algorithms, build AI algorithms that can actually improve energy efficiency uh, and reduce the demand on the power grid, right, by up to 40-50%. So that actually maps back to the goal that says we have to be more, more affordable in terms of energy and use more cleaner resources, right? And it's also by using AI and intelligently turning on, turning off things, you're also saying that you are being more responsible in terms of the consumption that you do, right? And any action that we take on energy savings means it is a direct impact to climate action. So what are the things that are happening globally, right? What we spoke about IPM Plus is what is happening in India, right? But what are the other things that are happening globally, and where is this trend of using AI for energy optimization going towards, right? One of the most widely used things that I'm sure a lot of you have been seeing is how do we use IoT and AI to make buildings smarter, make cities smarter, right? So this is one of a large adaptation going globally. In fact, it is growing at such a rate that it is predicted in the next 5 years, just that AI and IoT for smart buildings and automation will be a $60 billion market. So that's how much people are seeing the need for doing such initiatives, right? where you determine how many people are there, what lights to turn on, what kind of temperature to set, when to turn on, turn off air conditioning systems, when to use the grid power, when to switch to solar or renewable sources, right? Like giving your building a brain to make these decisions on your behalf, right? And the next thing is, especially in countries like India and China, where we have such a vast population and a pretty significant land mass, is how do we do microgrids? Right. One of the challenges, if you look at power and in energy and energy management, is distributing energy across the country. What are CHESCOMs, our BESCOM, and our local grids, right? We keep blaming them, saying uh, there are a lot of power cuts, but we really don't understand the problem that they go through today. They run one of the most complex networks in the world today, right? They have power lines going to every street, every building, within every building, to every home, all across the country, right? And managing this, ensuring there are no losses, no cuts, no power quality issues which can affect you, is a very, very challenging thing, right? So, what are things that we can do to make that job easier and more efficient? Is AI orchestrated local energy grids, right? There are a lot of programs happening in Germany, in India, in the rural parts of India, where a lot of enterprises and local governments are setting up small local microgrids that have more than one source of renewable power. Meaning to say, they have solar, they have wind, and they have some battery backups as well, which says a small community or a small village or a tribe can actually run their own power grid without having to rely and actually you know put so much pressure on powering them from the main grid, right? And this is actually making things more efficient and renewable also. There are no power losses because of large distance transmissions. You don't have to burn more coal or look at nuclear options, because um, India being in the geographical location that we are, 60% of our land can actually run purely out of solar itself, right? And that, fortunately, our government happens to recognize that, and that is why they're promoting so many programs into uh, pushing and subsidizing renewable energy and solar based energy for homes, offices. While on the other side, that we work on reducing energy consumption and finding cleaner ways to generate energy, there is this whole interesting financial section on saying, how do we make this a business, right? Which is kind of what defines everything today, is how do you bring in blockchain and AI agents that actually work as negotiators between person producing energy and person consuming the energy, right? And this kind of adds back to the whole previous trend of building microgrids, right? So when you build microgrids and when you build more, put a solar panel on everyone's home, now there is no central thermal plant or coal plant or a hydro plant where you produce energy, right? Every home is a producer of energy, right? There may be some people producing more, there may be some people producing less. So there's always going to be this traditional computer science problem of a producer consumer, right? So that trivial concept that we do in economics and computer science is equally applicable for energy management and energy trading here, right? So a lot of companies actually in the West who are investing into this, because they feel that the whole energy trading and carbon trading that is going to come up thanks to UN and SDG goals is going to open up a lot more opportunities for players and market spaces. Right? So I'm sure all of you know about UPI, right? How we in India revolutionized the whole financial and peer-to-peer payments. The same team from UPI is also quietly working on something called UEI, right? Unified Energy Interface. What this means is there are a lot of people making, just similar to how, if you draw parallel to banks, you have hundreds of banks, cooperative banks within the country, but and hundred of payment methods used to be there: debit cards, cash, credit cards, uh, wallets like Paytm, and so on. What UPI did is it said, I'm going to be a central mechanism or a path on which all of you can talk to one another and transact with one another, right? So which made life a lot easier for us. And why this UEI exists is when we start creating so many microgrids, so many producers, so many consumers, now everybody's going to be producing energy in ways they want, consuming energies in way they want. There's going to be a whole lot of carbon credit markets, carbon credit resellers, right? Which a lot of industries, polluting industries, especially like chemical industries and so on, will be interested in purchasing, right? So there's going to be hundreds and millions of players in this field. And of course, there's also going to be companies like us who are into building energy saving systems or energy monitoring systems, right? How do you make sure all of these systems are interoperable, can benefit out of one another the same way UPI has done? So UEI is going to become that interface for energy management in India, right? So this is a pretty large and open area that is quite unexplored, to be honest, today. Good that Beckon team is working on UEI, but it'll require a lot more, you know, support and integration from all the players to make it a big success. Right. So I mentioned about, how we had a challenge of building AI for laptops and desktops to save power, right? That we did and solved that problem for laptops and desktops. But what about the rest of the world? Your machines, your phones, your TVs, everything is smart today, including washing machines, right? I started seeing, stores saying there's AI washing machines. We don't know what that means, but what we do know that there's some unnecessary compute put into it, so it's going to consume a lot more power, right? And there's also like a lot of traditional infrastructure or old school infrastructure that already exists, which you cannot replace because of their cost and a lack of having a way to recycle or dispose them as well, right? So that means there is going to be a lot of challenges in bringing AI and retrofit it into the world that we live in. One of the key things for AI being data, right? So all these traditional systems, traditional and non-computer equipments actually lack data itself to take any action to build any AI, right? So if there's going to be a whole, you know, development, there is happening, not going to be, there is a lot of uh, pressure that runs on IoT systems to be able to build sensors that can retrofit and collect quality data from all these missions so that you can actually build an AI model that helps you move towards energy optimization. Right? There's also going to be the whole problem of scaling these and integrating. So I'm sure a lot of you have heard about Grok, the AI from Elon Musk as a part of his X or Twitter integration, right? one thing that was in Elon Musk's advantage was that they had a lot of money and a capital to spare. And they knew that using that money would buy them a huge market share, right, for their AI system, which is the biggest thing happening in the world today. So what they did is they said, we're going to roll out a huge AI model like nothing before, 10 times better than what Google and Microsoft, OpenAI has done, and we're going to give out a free version to everyone. What this meant is there are going to be millions and billions of users who want to experience it, who are going to abuse those systems and expect things to happen in milliseconds, right? So they had the problem of being able to, they had the problem that they had to scale to that extent. And just like any other traditional Western approach, solving something at scale means pouring more money into it, more resources into it, which Western countries do have, a benefit that they enjoy. So they poured in a lot of money and bought nearly 1.2 lakh GPUs to power that single AI system, right? But what this did and what they didn't anticipate is the energy consumption and the cooling required for that. So if you look at it as things scale, as we start saying, because we need data from more traditional systems, there are going to be millions of IoT devices globally that need to talk to data centers, that need to store data, that need power themselves for running, right? So we're always going to have this problem of scaling the same way Elon Musk did. But we'll have to find better ways of solving this. Uh, just to give an hint on how he's trying to solve it is he says, I cannot continue to pay the grid for power. Solar will not be enough. So I'm going to build my own hydrogen plant, right? It's only a crazy person like him that and who has that kind of resources can take actions like that. But for the rest of us on the other side of the world, we have to find more unique and innovative ways, right? Or what people call the Indian Jugaad way, because we have different scenarios and different levels of scales that we need to go up to, right? So most Western countries, European countries talk about going nationwide. They're talking about serving or building things for a few hundred millions of people, right? For us, a few hundred million people is a couple of states. That's it. So anything that we do, we have to think about how do we make it efficient in terms of power, cost, and scalability for nearly 1.5 billion people, right? And that's always going to be a challenge with anything that we do in India, but it is a good challenge to have. Yeah. So where can we begin with these challenges, right? The best place and the earliest place to start is in the education system itself. Every student today, be it at any point in his education journey, can be from nursery to degree to their postgraduate, their PhD research, needs to be aware of what is what is AI, what is the energy requirement, what is the impact of doing this, and we should ensure that these are imbibed in their brains from day one, saying anything that they do, any AI that they build, is always energy aware, right? We cannot have this whole world building so many amazing applications that use ChatGPT or Gemini or such large power-hungry AIs for doing something very trivial, right? So that's where we have to start ensuring. I mean, you have to start ensuring that from a college level, these things are put into the head of students so that the moment they come out of the institution, they know that they are responsible for something, right? And it also becomes a research opportunity for institutions in general. And this is domain agnostics, right? It requires domain knowledge, it requires computer science knowledge, and definitely maths as well. So you can help towards building and researching into thesis which help build more energy aware algorithms for multiple use cases. Can be machines, smart offices, smart classrooms, right, or smart campuses itself. How do you look at reducing power consumption and carbon footprint at a campus level, right? There are two things that are happening that I keep seeing when I visit colleges is they're seeing the need for AI. How do we make digital infrastructure the next big thing so that every person that comes out of that institution is employable on day one, right? But what they're not seeing is how do I also make sure that I am sustainable at the same time while using this AI, right? You don't want to be doing more damage than the good cause that you uh, live for. There's also going to be a lot of opportunities on how do we build interactive systems that bring in a sense of human element into AI, right? See, if you look at AI, typically what it has done is it has democratized data, it has democratized knowledge. But what it cannot do in your data pyramid is the top of the pyramid, that is the wisdom that mentors, teachers, and elders have, is not something that can be taught by AI, right? So there is a lot of academic opportunities and research opportunities on how you can build a AI-driven ecosystem that still has a human touch to it for things that go around sustainability and efficiency, right? And of course, this cannot be done alone. It is not a one person or a one man show. This has got to be a collaboration between everybody because it's everybody's responsibility. It's both the researchers and academicians' responsibility and equally an industrialist's responsibility, right? So there are definitely a lot of opportunities that we can explore and see how building sustainable AI is something that to the needs of the industries can be done right from the academic level itself, right? And I'm happy to say that there are a lot of institutions and bodies in Bangalore itself who are actually doing this. One such institution is called a Computing Foundation, whose entire uh, reason for existence is showing the world, showing everybody how do you follow better and sustainable practices and responsible practices in terms of IT, coding, programming, technology, and AI while making sure you do not cause a lot of damage to our environment. Yeah. So I wanted to dig a little deeper into how academic institutions can actually drive this change, right? One being the green campus initiatives. Your institutions, your buildings, right? Not only should they be more digital first, more AI first, but they should also be powering this digital and AI through renewable sources that you yourself are generating, right? And you can also always have a lot of monitoring and IoT systems which tell you exactly how much power you're using, where are you using power, when are you using power. And these can even become your own data sets for your students to actually work on their AI, right? That kind of quality and local problems that they can solve with AI, the campuses themselves, sustainable campuses themselves can become these data sources, right? And at the same time, for the institution, it is actually saving them a lot of money in terms of energy bills. Right? Another thing is to get this into the curriculum itself. how do we make sure that every code that is written, every engineering problem that is solved in any field, right? Every building that is built, every machine that is designed, every application that is designed by any student, any teacher, and anybody in the world is always energy aware and done keeping in mind that there isn't infinite energy and resources to spend, right? And this can be done through having courses on sustainability, green IT, green infrastructure that are in turn as a correlation or as a subset of AI courses as well, right? Because both have to go together for us to be a more sustainable world and to move towards implementing all the sustainable development goals by UN. And I completely understand that this is not possible by one person, which is where industries relationship with a lot of industries and would benefit institutions largely, right? Both in terms of helping build and do better research and innovation, bringing in student internships, giving them an idea of how the industry works and how all the knowledge that they have gained in the institution on being sustainable can be applied over there into the real world, right? Yeah. So I just want to end this by saying that there is a real need for AI, and but an equal need for sustainability, right? And we cannot do it independently. We cannot even do it together 24/7, but we can use and build more sustainable AI that can do this. Both industries and companies like us, as well as institutions as yourself, all of us are equally responsible as citizens of Earth to make sure we all, move towards achieving all these sustainable development goals, right? And one of the best and most important ways to do this is by making IT greener, because every like that we do on Instagram, Facebook, every share we do on WhatsApp is actually coming back and hurting us because it heats up some server somewhere in the world, right? So let's make green IT as a default thing for all of us. Yeah. And thank you for patiently listening. I'm happy to take any questions that you have.
Dear participants, any queries? Vidya ma'am?
Yes, ma'am. Thank you, sir. Dear participants, if you have any queries, please post in the chat box. Raise your hands. Okay, so let me conclude the session. So thank you, Harsha sir, for delivering such an insightful and engaging session. Your perspectives on AI, IoT, and sustainability have truly inspired us to think innovatively. We deeply value the knowledge and experiences you share with our audience. Your contribution will certainly leave a lasting impact on our learning journey. I once again extend my heartfelt thanks to you, sir. I also thank all the participants for your active involvement and enthusiasm. So, with this, we conclude today's session. So, thank you all. Have a wonderful day.
Yes, thank you.
Thank you,
Thanks,
sir.
everybody.